Alright, CNT120, Chapter 4. We're going to focus in on protocols in this chapter. So we want to look at TCP/IP core protocols and then some of the protocols around those and things related to that. That'll include some encryption and some utilities with TCP/IP, some of your troubleshooting and utility commands. Alright, let's start off with TCP/IP in general. TCP/IP, we tend to refer to it as like a protocol suite. As I like to think of it, TCP/IP is almost like a bucket of protocols. So if you think of all the protocols that get things done and kind of put them in a bucket, TCP/IP is that. It is a bucket of protocols that if you want to send an email, boom, this SMTP protocol gets used. If you want to transfer a file, boom, FTP protocol gets used. If you want to transfer or load a web page, boom, HTTP protocol gets used. And these are all part of the TCP/IP protocol suite. And in there are some specific ones, TCP, IP, UDP, ARP. These are ones we're going to be zeroing in on this chapter. This was actually developed by Department of Defense, the DARPA project, and this became I should say, actually, its development came from a Defense Department research project called ARPANET, which became what we know as the Internet today. So these protocols were developed out of that need for communicating between systems, if you will. The advantage of TCP/IP is it doesn't cost anything to use. There's no licensing. It's open nature. Any operating system, any platform can run this. Windows, Linux, Apple. Once upon a time, Windows would use its own set of protocols. Apple was using its own set of protocols. Novell was using its own set of protocols. They were all doing their own thing. TCP kind of eventually became the default standard that everybody used. So by today's standards, any operating system can run TCP/IP. It costs nothing to run. So it's this common protocol we all use, common set of protocols we use for communication purposes. So let's take a look real quick. I'm going to pull up the network settings on my computer, on my laptop that I have here. So I'm going to open my network and internet settings. Let me get my window just a little smaller so you can see what I'm doing. This is just my Windows laptop. I'm using my wireless card right now, but I'm going to go to the Network and Sharing Center, and I'm going to look specifically at my wireless card. So I'm going to open that up. When I go to Properties here, what I'll see, these are the clients, services, and protocols installed on my system. And if I take a look through, there's Client for Microsoft Networks. That allows me to do Windows Client Server networking, if you will. The next one here is File and Printer Sharing. That's a service. This allows me to do peer-to-peer on a Windows network. I'm going to scroll down a little further, and now I see TCP/IP version 4. So TCP/IP is installed on here. That is the bucket of protocols installed on here that I'm going to use to communicate. Once upon a time, this was not installed on your machine out of the gate. You literally need to go to the install option here and say, hey, I want to install a protocol, and literally install this on your system. I recall once upon a time, this is a good 20 years ago, more than 20 years ago, when we joined our church, they were working on networking the computers together, and some of the guys in there were not familiar with TCP/IP yet. They were going to use what was called NetBEUI. It's a non-routable networking protocol to connect the secretary and the pastor's computer and that sort of thing. They were going to use that to network the computers, and I said, why don't we use TCP/IP? And they kind of looked at me like, well, if you know how to do it. I'm like, well, of course. So we got it set up from day one in that case that these computers were networked. But this is the common set of protocols that all of our computers use to communicate. And you also notice down here TCP/IP version 6 is down here and installed as well. Just a little side note for future. So my system is set up to do that, and if you start checking your systems, whether they be Apple or Linux, you're going to find that TCP/IP is installed in there on your system, and that is how you're able to send emails, that is how you're able to browse web pages, etc. This is the common bucket of protocols that are installed on your system for communication purposes. Well, our TCP/IP protocols have their own model. Don't panic. The nice part is this model sits kind of like on top of the OSI model. It's just 4 layers. So some of the OSI models get squished together to make the TCP/IP model. So if I take a look here, here's the OSI model over on the right: application, presentation, session, transport, network, data link, physical. On the left over here is the TCP/IP model. And as you'll see, the upper 3 layers of the OSI get combined together to be the application layer. Transport stays the same. Network, the name changes, but it kind of makes sense because this is where internetworking occurs. This is where the routers are functioning to move data around. And then the bottom 2 layers down here get combined to be called network access, which also makes sense because my network card is here and my cabling is here. Those kind of go together. Those kind of go together to give me network access. So that kind of makes sense. Here's our TCP/IP model. Familiarity is the key to recognize this. Okay, a lot of what you're going to do from here on out is be focusing on protocols, and it's nice to know the framework they fit in. It's nice to know the framework that they fit into. TCP/IP is routable. Like I said, my example from, over 20 years ago, the guys at the church were going to install NetBUI on the routers or the workstations to move data around, there's nothing wrong with that. But as we want to put our Netgear Linksys router in a couple years later, we would have had to change the whole protocol stack anyway, because NetBUI was not going to be able to be routed through, our Verizon, Comcast, whatever router we were going to be using to get internet service. So setting up TCP/IP from the get-go there was a huge help to them. Remember that as we were talking data encapsulation, we had the packaging of data for shipping purposes, the data encapsulation. So remember, layer 765, this data is known as payload. So if we think back to our data encapsulation when we talked about OSI model back in chapter 1, if I have a piece of web page, that really does not change up here in these upper layers. It still remains data, if you will. It's when we get to layer 4, our transport layer, that a header gets added to identify the service it needs to go to on the other end, whether it be a piece of email, whether it be a piece of web page, whether it be a piece of file that we're transferring. And that header, TCP or UDP, gets added there to identify what service is this going to. Is this going to a my web browser on the other machine, or what is it? At layer 3, remember, we're adding the IP header, the IP addressing, so we know where it's going to. So the IP header is containing that IP addressing. Layer 2, remember, we're adding the Ethernet. This is typically going on an Ethernet network, so we're typically going to be dealing with an Ethernet frame. So we would have the source and destination MAC address for this, and this ends up becoming an Ethernet header that has the source and destination MAC address in. And then layer 1 is literally our ones and zeros sending across the network as pulses of electricity, pulse, nothing, or light pulses if we're sending across fiber optic. Pulse of light for 1, no pulse for 0 kind of thing. And hopefully you remember this picture from before. We encapsulate on the sending end. It goes across the network as ones and zeros, and the receiving end is going to decapsulate. It's going to carefully take these headers off and go, is this for me? Tear it off, is this for me? Tear it off, is this for me? And keep processing it up through the layers to hopefully the service or application running on that device. Remember also your, don't send fill for bill for your data segment packets, frames, bits. All this is kind of coming back from chapter 1. Don't forget about those. So at my TCP/IP core protocols, our connectivity devices usually are referred to by the highest layer of data that they read. So switches are typically layer 2, which means they typically read layer 2 addressing, MAC addresses. So typically switches are layer 2 because they're reading layer 2 header information, which is our MAC addresses. Routers are typically layer 3, so they're going to read the layer 3 header, which is our IP addressing. And things like firewalls are typically layer 4, could be higher, but typically layer 4 because they're going to read, in addition to the IP, they're also going to read those port numbers. Is this port of traffic allowed through? Is this port of traffic allowed through, etc. So we typically refer to them by the highest layer that they read. Switch is typically layer 2, router is typically layer 3, firewall is layer 4. Okay, or if I think of the addressing, if you want, MAC address layer 2, IP address layer 3, firewall port number layer 4 kind of thing. However you want to try to remember those. All right, when we come back in the next podcast, we're going to dig into that first protocol that's in the book, TCP.